Welcome to this video. This is Saeed Ahmed. So in this video, I will describe some key points from a research paper on model-driven development and model-driven engineering. So I can share the paper. Okay, this is the paper that you can see. It is in the public domain, publicly available. So the paper is about grand challenges in model-driven engineering and analysis of the state of the research. So you can see challenges in model-driven development and model-driven engineering, and it will be just give you an analysis of the state of the research. Okay, so what is model-driven development? Model-driven development, it's a software engineering aspect, right? Software engineering aspect. So you create some model thing for the software that you develop. You create some model, and depending on those models, you develop the software. Now, the idea on how to create model or how to engineer the total process, that's the model-driven engineering, just very lightly, roughly. Yeah. So defining was not my goal. Anyway, so what this paper has done, yeah, yes, they have discussed the grand challenges in model-driven development and model-driven engineering. Now, so what are those challenges, right? They discussed. So before that, I believe I can give you an idea. Let's see. So there was some two events on. There was two events of 2017 and 2018 on model-driven engineering. Model-driven engineering. The researchers in this field discussed the current state of the research for model-driven engineering, and what are the challenges, what might be the possible solutions, or what might be the future. So this paper has published those discussions, outcome of the discussions, or what was discussed there. It just discussed those and give some perspective. So if I want to introduce the paper, as I told, they presented and analyzed grand challenges on model-driven engineering from two events, 2017 and 2018. And then the challenges they discussed, they divided in multiple different ways. One thing was chronological order. Chronological order means by years. By years, say before 2007. Before 2007, that is one, and after 2007 until 2018, right? 2018, because the events were on the 2018, 17 and 18. Now the paper got published in 2020. Okay. So some more insight after 2018 may have been there, may have come into the paper, but the thing is, the goal was to discuss what was discussed in those two events in 2017 and 2018, and what was the challenges and solutions, or what they can do within that event. So anyway, one thing is chronological, before 2007 or 2007 to 2018 or present day, and another way they divided the challenges in some technical domains, some technical areas of model-driven engineering, right? Technical, yeah, I think words in the technical domain, you know. Okay, they also subcategorized the technical challenges, right? You can say domain challenge, function, foundation, all all those challenges. Okay. Now there are some social and community aspects of the challenges in model-driven engineering, right? Social aspects and community aspects. It's about uh, using MD, adopting MD, teaching MD. So all those challenges. Okay. So as I told before, this paper also has provided some future uh, direction as well. Now, some technical challenges can be domain challenges, creating tools, and foundation challenges, and social and community challenges. I told social aspect is one thing, and community aspect is I think social is the general social thing, and the community for different particular communities. What are the challenges? So now, what was the challenges or focus of the research before 2007? The primary challenge was modeling. The primary challenge was modeling and modeling languages. Modeling and modeling languages such as UML, Unified Modeling Languages. So update and improve modeling language such as code generation of from UML models. That was one of the core challenge and work that was done before 2007. And also standardization of different related uh, tools, language, or modeling concepts. So, or the related uh, related things, right? Just standardization, so that everybody is coherent, can consistent. So, one thing is meta object facility, right? Meta object facility, standardization of meta object facility, standardization of MDA, model driven architecture, and object constraint language, query view transformation. Query view transformation, standardization of these languages. Those were some work that was done before 2007. Okay. So between 2007 to 2018, 2019, there are several work. I think one thing is challenge. Another thing is what was the hot work, uh, what got worked on in terms of research. That means what areas research focus. That means those there are challenges in those areas to improve on, right? So yeah, language engineering. So how to use modeling languages and the associated tools to facilitate development. That was one of the focus. And language workbench. Language workbench, it's an environment, right? It's a total environment where you can use model-driven development, model-driven engineering to develop software. I think it was the challenges related to creating and working, or how to make a workbench useful. Uh, so that was one another area of challenges in MD research. And then model management. So when you are creating models for different systems or software, how do you manage those model, right? Evolving, uh, evolving those model, or probably how different model can coexist or not, or with the changes of different components, how do still you manage the model? So that is a sort of, you can say, model uh, management. I think it's about creating, manipulating, maintaining models that are used to represent and specify software systems. Yeah, those models that are used for specify or represent software system. How do you create them, manipulate them, maintain them? That is the thing, I think. Yeah. So that was one of the important research problem or research that got worked on. And then model analysis. Yes, you are managing them, and then whether your model is correct or not, right? Whether your model is correct or not, the validation, debugging, verification, simulation of models, that is one another area that also got worked on, and that there are challenges there as well. And then the model transformations, right? Model transformation. Okay, model transformation is, I think, converting one model to another, or model to text, model to model transformation, or model to text transformation. So when you're creating code from models, those, I think those are some areas. Still, there are challenges remaining. And then models at runtime. Somewhat addressed the models at runtime. Like when model in execution, model is inside the software system and it is doing something, right? In that case, if any error happens, how to do with that? And how to monitor? And sometimes we also create some more model for software monitoring. So how to best create that, or how to best make best use of that will be something that got worked on. Modeling repositories. It's about storing models. I think the work that addressed how to store different models. I think sometimes we need to store models so that we can use it for different software, right, within the same domain. Or sometimes it can be generalist, but I think in general, because it can be domain specific as well, right? Particular domain as well. And scalability. Scalability of models or model-driven engineering in different dimensions. That was one other area that got worked on before 2000. No, not before. In between 2007 and 2018, 2019, right? So how did I tell the primary criteria after 2007 to 2018, 19? Language engineering, language workbench, model management, model analysis, model transformation, models at runtime, modeling repositories, and scalability of this. So those are the chronological order or chronological discussion of the work and challenges in model-driven engineering. Now, what are the other ways it got divided? One thing is this technical challenge and the social and community challenge, right? Technical challenge, social and community challenge. Those are two other challenges. It is not in the chronological. It is the work area based categorization. This one also has discussed the research challenges or the research work that were carried on in different challenge categories. Okay, so I think technical challenge, social and community challenge, right? Technical challenge, it got divided into multiple areas like foundation, domain, and tool. Foundational challenge, domain challenge, and tool challenge. Foundation. Foundation, you understand, is the foundation of the language, foundation of the model-driven engineering, right? So all the related languages. So let's say foundation, right? Yeah, conceptual and theoretical aspects. Conceptual and theoretical aspects of MD, that is under it. There are also all the aspects of software development, modeling, deployment, execution, and maintenance. Those are the some foundational the challenges. One example challenge can be how to allow legacy models to coexist with current model, right? So it probably falls under the model management. Legacy models, how to coexist the current models and current technologies. So foundational challenge, conceptual and theoretical aspects of model-driven engineering. And domain challenges, I think it's about adoption of model-driven engineering in particular domain. Particular domain means finance or aerospace or automobiles, right? So how to uh, make model-driven engineering suitable for different domains and how to make it domain specific. I think if you make it domain specific, then you probably can give some additional stuff that is specific for that, and then developing software for that particular domain can be easier, right? So there is one another concept, domain specific language, uh, domain specific anyway. So the word that went addressing the uh, addressing models for a particular domain or for different domains, or the challenges for a particular domain for MDE, and how to align model or MDE for that, and how to develop and how to make it suitable for the nature of the application that got addressed in this domain challenges. And also reliability, security, integration of data. Those are some other areas where work was done in relation to MDE and MDD. So tools. Tools, it's about development of tools or integration of different ideas or concepts or strategies within the tools. So that got into this domain. Now, lack of tools. Lack of tools is one reason that MDE or MDD did not get high adoption. So lack of tools is one. So some research went on, and there are some research challenges in tools and implementation areas. I think some of them are adopting. I think some work was on the adopting textual languages and treating the code as model. If we can do that, and then can it help in the MD based software development, right? Adopting textual language and treating the code as model, and also some creating some good and easy tooling like the modern ID, some ID, so that software can be easily developed, and also component-based solutions and high-quality generated code. Those are some other areas that got worked on, right? Okay, and also creating visual editors to make the development faster, and also how to combine the different heterogeneous views and artifacts and make them work together. Those are some areas it got worked on. So those are technical challenges, foundation, domain and tool. Now social and community aspect, right? Usually, yes, MD good or bad or how good you can make it, but eventually the adoption, it's depends on the social and community aspects, right? So if the society and community likes it, they will use it. If they don't like it, they will not use it. But probably one thing is how to make them to like it, how to make the social and community to like it, right? And another thing is uh, how to teach them, how to make it easier for adoption. Those are some of the areas, right? That also worked on, or the challenges are still remaining there to be worked on. And social aspect, yes, some challenges are there and some are being worked on creating MD tools so that non-technical people can use MD tools. Non-technical people can use them to create some to create software. Okay, sometimes some work can focus on the example-based modeling. Example-based modeling, I believe, so domain-based models. Those can also help adoption, but that probably falls under community aspect. Yeah, social is overall. What are the community aspects related challenges, or what was being worked on, or what challenges still are there? The thing is, individual cannot easily address social community challenges, right? Community challenges, individual cannot address it, so community has to work together. So another thing is the MD community itself. There are some challenges that they did not work together collaboratively to make MD tool popular. So some challenges are there that needs to be worked on to make MDE useful. And also, the community can create a model repository, and the models could be rated by community, and the others can use it. That's it can help to adopt MDE as well. Another community challenge is how do you teach? How do you teach students model-driven engineering? That is another community-based challenges. Anyway, so at this moment, I try to describe the technical challenge in subcategories and also social and community challenges that were there, that was being worked on, and some more challenges were there. So some ideas, right? Now, yeah, the paper has mentioned on them one by one. I also mentioned them to some extent the same way. What are the most critical challenges among all of these challenges? What are the most critical challenges that these events found, or whatever the researchers they are discussed, the most uh, pressing, most important technical challenges, right? So let's see, one of the thing was model management, right? Model management, and then understanding the principles of building visual editors. I think it falls into the building visual editors so that it makes it easier to develop. But I think visualizing, utilizing the visualization principles can be tricky, and some improvements are needed. And scalable of the models or MD in different dimensions. That was one of the core and tricky challenge that still remains. And improve MD solutions. MD solutions such as support agile processes, and also increasing the usability of the models and model transformation techniques, so that you can model to model transformation, model to code transformation. So we need to improve the usability. That is still a core challenge. Model-driven engineering utilizing that IoT and smart systems. Yeah, they are good candidates, but further workers are required that got identified. And also in social and community aspects, I think one of the core pressing challenges how to determine the success of MDD, right? Determine the success of MDD and how to teach MDD or MDE. So those are some pressing technical challenges. So what is the limitations of this paper? The limitations of this paper, yes, they I think we saw the challenges in chronological order, uh, or different categories, right? Now, one of the challenges or limitations that it seemed to me for the paper is that I think the different thing, how they evolved over the time, and how they overlapped with other domains and influenced the evolution of different tools and languages, that probably would be further addressed. So, and on another note, yes, I believe as for the paper, if any tools got developed from the ideas or the challenges identified, one thing is I tried to see if any tools are there. What are the recent tools in this domain? So I got some tools, and it looks like they might have addressed the challenges discussed here. These are some recent tools that are being used today. I took the name from a recent article by one of the authors, and that way I'm just inferring, yes, the tools are there. They are trying to work on the different challenge areas. So if they have got developed, my perception is they might have utilized those ideas. Okay. Okay, some of the tools that I can see, that AI visual modeling tools. So visual modeling, visual editors, that domain I know. Machine learning studio, okay. SPSS modeler. Yeah, there are some other AutoML, Lobe, HMR. There's a couple of tools. Okay. So what can be the future direction that you can draw from this paper, right? Yeah, one thing is, I think as the paper had discussed, where not much work is done, the minimal work areas, minimal progress areas, the future research can work in these areas, right? So one aspect, one limitations, they are saying that the teaching environment for MDE or reaching communities, those are still a major challenge. I think at one end, when technology will mature, social and community aspect will need to be addressed so that it gets adopted. So teaching environment getting, that is important. And also making MD tools more intelligent, self-aware. That is definitely an area to work on in future, because that's the trend right now, and that for a good reason, right? So yeah, improve the autonomy of MD tools, improve the autonomy and collaboration of MD tools. Yeah, I think different MD tools, collaboration, and make the collaboration autonomous. So those will be some of the important areas to work on. Okay, bye.